Okay, Algebra 2, this is nothing new for this lesson. This is just review. All right, so we're going to review last couple homework assignments that we did with reciprocal functions and our rational functions. So this is homework 8. It's just review. So our parent function for our reciprocal function was 1 over x. All right, it looks like this. All right, and we can talk about the vertical asymptote, which is at x equals 0, which is the y-axis, and y equals 0, or the x-axis, is our horizontal asymptote. The domain for this is all real numbers except for x cannot be equal to 0, and the range, all real numbers, but we can't have y equal to 0. All right. Next is standard form. Standard form is f of x equals a over x minus h plus k. There's nothing special about standard form. It's just that we're now going to, the a is going to contribute to the vertical stretch or shrink. The h is going to be horizontal shift left or right. And k is going to be vertical shift up or down. So we can move these things around, and that's what all these words are. So let me go ahead and fill those out for you. H is the horizontal shift. Positive, you go left, and negative, you go right. K is the vertical shift. Positive shifts up, negative shifts down. If a is negative, the function is reflected across the x-axis or over the x-axis. If the absolute value of a is greater than 1, that's a vertical stretch. And if it's between 0 and 1, like 1/2 for example, or negative 1/2, that is a vertical shrink. Vertical asymptote is x equals h, horizontal asymptote y equals k. So all this stuff is in your notes. I guess we just went back through it again. Hopefully some more examples will help as well. So here's another example. So here's our reciprocal function. This one, it does not have any vertical stretch or shrink. It is moved 1 unit to the left and 5 units down. So I'm going to go 1 unit to the left and then 1, 2, 3, 4, 5. And I'm going to put the intersection of my horizontal and vertical asymptote. So whereas before the horizontal and vertical asymptote met at the origin, this time they meet at the new center, I'll call it, of this function. And then it's pretty much the same thing, where it's the hyperbola that looks like this. It's not perfect, but you get the idea. All right, so our vertical asymptote is the line x equals -1. Our horizontal asymptote is the line y equals -5. So the domain is going to be all real numbers, except for x cannot be one number, and that number is -1. And then for the range, all real numbers, y cannot be one number, and that one number is -5. All right, we'll do a few more of these in a second for extra practice. There is another one here you guys can try, but obviously the homework is going to be many, many more just like this. All right, we can always check in our calculator, so don't forget that we graphed these things, and we typed it in as alpha y equals as a fraction, and then 1 over x plus 1, and then you have the -5, and you can take a look, and it looks like the graph that we have here. And you can find features of it and make sure they're consistent with where they should be on the graph. Things like the y-intercept, for example, and make sure you get that right where it should be. Now, obviously, I can find the y-intercept by doing second calculate value and plug in 0 for x. All right, and so that's -4. And you can always do the same thing up here. Plug in 0 for x, and like we did earlier in the year, and you'll get 1 minus 5 is -4. So 0, -4 is where I should have had the y-intercept. So my graph was off a little bit. So things like that, you can use your calculator whenever you guys need to double check. All right, let's try some rational functions. Okay, rational functions have the form, we call this p of x in the top over q of x. Now what p and q represent are just any two functions or algebraic expressions. It could be, x squared over x. Like this example over here. You have x squared minus 9 over x plus 2. All right, p of x is representing this function in the numerator, this quadratic, and then q of x is representing this line that's in the bottom. All right, so the x-intercepts, to find those, we just set the numerator p of x, what's in the top, equal to 0. All right, vertical asymptotes, we find those by setting the bottom, q of x, equal to 0. Okay, for horizontal asymptotes, we have 3 different situations. If the degree is higher in the top than the bottom, there's no horizontal asymptote. If the degree of the top is less than the degree of the bottom, it's going to be the x-axis, or y equals 0 as your asymptote. And if the degree is equal in the top and the bottom, then you do a fraction of your leading coefficient between the top and the bottom. So for example, over here, you would do y equals 1. 1 over 1 is 1, so it'd be y equals 1. We'll do that one in a second, or one similar to it. All right. Okay, now holes, you know, that little break in the graph, those are just, you know, common factors. So if you have a common factor that cancels, set that common factor equal to 0, you'll get your x coordinate. Plug that point in, you'll get your y coordinate. All right, so let's do some examples. Okay, we have x squared minus 9 over x plus 2 for this example. Now, always factor this and try to simplify. So I'm going to make this x minus 3x plus 3 in the top because that is a difference of 2 squares, and we know how to factor that pretty easily. So there's no factor that cancels, so there's no holes. All right, but I can find my, first of all, x-intercept. X-intercept, we set the numerator equal to 0, so I'm going to take the top, set it equal to 0. Now, when I take x minus 3, x plus 3, and I set it equal to 0, there's 2 things that can give me the 0, 3 and negative 3. So my x-intercept is going to be 3, and I'm going to do the 3, 0, and negative 3, 0, give them as ordered pair. All right, holes, there's none like we talked about. Vertical asymptotes, we set the bottom equal to 0. So that's x plus 2 equals 0. We're going to subtract 2 from both sides, and we get negative 2. So the vertical asymptote is that x equals negative 2. I'm going to start to sketch some of these things on the graph. So there you go. The vertical asymptote's there, as well as both x-intercepts. All right. The domain, now it's all real numbers except for this vertical asymptote. So I'm going to say all real numbers except for x cannot be equal to negative 2, because that would mean we'd be dividing by 0, which doesn't make any sense in math. All right, horizontal asymptote. Now, the exponent's higher in the top than the bottom, so that's the top one here. P is higher than Q, the degree of P, meaning the exponent's higher in the top than the bottom, so there's no horizontal asymptote. And the range then is going to be all real numbers. All right, now what does this graph look like? Sometimes, you know, it might be helpful to graph a few other points. You know, just plug in, for example, like, I don't know, negative 4, negative 5. You're going to find out that point's down here. So the graph looks like this. All right, that's kind of a weird one. It does have an end behavior asymptote, but yeah, we're not going to worry about that end behavior asymptote that goes on a slant for now. All right, we'll get to that later in math. But once again, just go ahead and double check this on your calculator or use it as a tool if you need it. X squared minus 9 over x plus 2. Take a look at the graph, and it should look like ours. All right, let's do some other examples then with the remaining time. YouTube only lets me publish 15-minute videos, so let's try to find some other examples to do to fill up this time and to get you guys some more practice, hopefully. So we've covered both reciprocal functions and rational functions. So now let's just do, the homework is going to be just a variety of examples of each kind of function. Okay, so we've done kind of one like number 1 a second ago, so let's do number 2 here. Number 2 has a vertical stretch and a reflection over the x-axis, and then it's been shifted up 6 units. All right, so let's start by, I guess, graphing the x-intercept. Okay, the x-intercept is where y equals 0. So the question is, where is this thing equal to 0? 0 equals negative 2 over x plus 6. Subtract 6 from both sides. Let's cross multiply. So please excuse my cat there. Divide both sides by negative 6. All right, and you get x equals 1/3. So 1/3, really close to the x-axis, is our intercept. Or close to the y-axis. There's our x-intercept. All right, and now let's find our asymptotes. So first of all, our vertical asymptote occurs at 0s at the bottom. So our vertical asymptote is the y-axis. A horizontal asymptote then, since the exponent's higher in the top than the bottom, it would be the x-axis, but it's been shifted up 6 units. So 1, 2, 3, 4, 5, 6. So now it's up here. And now this negative sign, normally the function goes like this, but it's been shifted up, so it would go like this. But because of the negative, it's been reflected over. So now this branch that was up here goes down here. So it's going to look like this, and the other branch is going to be up here. Now, if you want to find exact points, plug in, for example, like 2. If you plug in 2, you get -1 plus 6 is 5. So it really goes through 2, 1, 2, 3, 4, 5. So if you want to be more precise about your graph, you can always plug in points. And then obviously you can always use your calculator as well to double check these. So go to y equals, do the alpha fraction thing, -2 over x plus 6. Take a look at the graph. It should look like what we have. Once again, we can always find features or go to the table, and then all the points are graphed for us. One is at 4, which is right here. So my graph really wasn't the best. Yeah, so use the calculator as a tool. All right, let's jump down to number 4 then. We got time for maybe 1 or 2 more. All right, so here we have a rational function. All right, let's go ahead and factor it first. So I'm going to pull out a 2 from the numerator, and I'm left with x plus 1. And then in the bottom, I can make this x minus 1, x plus 1, because it's a difference of 2 squares pattern. All right, it looks like it's going to have a hole. That factor cancels, so it simplifies to 2 over x minus 1. All right, so there's our function now. So let's take a look at these things. The x-intercept, all right, that is where the numerator is equal to 0. In this case, the numerator is never equal to 0, so there is no x-intercept. Vertical asymptote occur at zeros at the bottom, so that's if you set the bottom equal to 0, that's just 1. So we're going to say x equals 1, and I'm going to graph that on here. All right. Horizontal asymptotes now, the exponent is higher in the bottom than the top, so it's the line y equals 0. So I'm going to try to draw. Okay, now our hole was the factor that canceled, so that's at x equals -1. You set that factor equal to 0. So -1, and then if you want to find the y value for that hole, just plug it in to the simplified function. So that'd be -1. So at -1, I'm going to put a little circle right here to remind myself that that's where our hole is. Okay. All right. Now our function, is our regular reciprocal function like this, and you can graph it some more points if you want, like we talked about. There is a couple more points, like the point 3, 1, which if you plug in 3, you get 1. If you plug in 2, you get 2. All right, so you can graph some more points here, or do it with the calculator. But there is a hole right there at -1, 1. So the domain is going to be all real numbers, except for x can't be that hole at -1, and it also can't be the vertical asymptote at 1. And then the y value is going to be all real numbers, but y cannot be that y value, the hole, which is -1. And then also the horizontal asymptote at 0. All right, now I'll do one more, but I'm going to have to fly through this one because YouTube's going to cut me off after 15 minutes, so I'll do a lot of pausing. But factor this first. Top, just pull out an x, and then at the bottom, I would factor just by guess and check. And this is the complete factorization. It is going to have a hole at x equals -5, and let's find that as an ordered pair. So plug -5 back into the simplified function, and you're going to get 5 over 13 when you do that. So kind of a weird fraction. All right. So that point is right here. 5/13 is a little less than 1/2. Okay, the x-intercept, set the top equal to 0. So that's right here at 0. Okay, vertical asymptotes occur at zeros of the bottom. So set the bottom equal to 0. You get 3/2. All right. Horizontal asymptotes now, the exponent's the same. So we do a ratio of the leading coefficients, which gives us y equals 1/2. 1 divided by 2. So let me graph both those asymptotes. All right, and then the function goes like this and like this. All right, so the domain then is going to be all real numbers except for this asymptote and this hole. Hole's at -5. Asymptote is at, asymptote is at 3/2. And then the range, all real numbers. Y can't be equal to 5/13, our hole, and then also 1/2, our horizontal asymptote. All right, I hope this helps, and please let me know if you have any